Take a moment to pause this video to read the full problem statement. What we're trying to find in these two parts are probabilities that involve, really underlying here, they involve the word and. So, for instance, in this first part where it says, assuming each component's failure or success is independent of others, what's the probability that all three components fail, resulting in disaster for the flight? So that means the probability that the first component fails and the second component fails and the third component fails. So because we're using and here, we really multiply the probability that the first fails times the probability that the second one fails times the probability that the third one fails. And because we're told here that these components' success or failure is independent of others, we have that same value of probability of failure for every component individually. So we could look at that as 0.0071 times itself, or we could just raise it to the third power. Either way, we get this value. Now keep in mind that when you do something like this in your calculator, you will get this shorthand notation, shorthand scientific notation. So I'm going to write that out here. That was, let's say 3.6, just for rounding's sake, 3.6 e negative 7 is what our calculator says. What that really means is 3.6 times 10 to the negative 7. So just be careful as you're typing this in to my math lab that you're expressing it as a decimal in standard form. So in other words, move that decimal 7 places to the left to make that a smaller value here, as so. And then for the next part, it asks, what is the probability at least one of the components does not fail? So in this case, I'm going to use the at least formula, I think is what our text calls it, where we do 1 minus the probability that all of them fail, which actually we just calculated that earlier. So I could do 1 minus the previous answer, for instance, right here in my calculator, and you can see it calculates it as such, and I could just round to 8 decimal places as needed. And that again was the at least formula for probabilities. So I've just tried to write that out a little bit more of a wordy way, I guess, but still using some math notation. Think of it like this: the probability that at least one does not fail, that could be, okay, 1 doesn't fail, 2 components do not fail, 3 components do not fail. There's lots of different possibilities, but the only way that will not happen is if all 3 fail. So that's why we can use the complement here, or the at least formula from our text.